Now, hosts like PCs and laptops and workstations are a big source of IoCs simply because they're most likely the ones to be compromised in any attack. So what kind of indicators can we look for? And we can start with the processes. What exactly is running on the host? Now, when looking for active malicious processes on the hosts, it helps to have a predefined baseline. That includes what processes you can expect to run, when they should run, who should be launching them, how many of each of them should be running at any given point in time. This way you can immediately figure out which processes don't match that baseline and might indicate a compromise. Other malware types, also attacking running processes, can load the malware code as a dynamic library, like a DLL file on Windows, thus injecting itself into a valid process in the operating system. This makes it a bit more difficult to detect, since the process list will not give away any indication of a malicious library or an external process. So instead of looking at the processes, we need to look at their behaviors. And when speaking about behaviors, we can think about, let's say, for a legitimate process. Abnormal behavior might be any of the following, like unexpected changes to the Windows registry, accessing new locations on the disk, new files that process would normally not access, unexpected network activity, especially obvious for processes that don't normally generate any network traffic. Now, among the tools that you have at your disposal for monitoring processes, you probably know about Windows Task Manager, of course. A Process Explorer is, in my opinion, a much better type of application. It comes packed in the Sysinternals utility pack, available for Windows for free. On Linux systems, you can use the PS commands with a lot of switches, or the top command, or even the much nicer looking htop command to monitor resource usage and active processes. And on Mac OS, you get Activity Monitor and pretty much all the classical Unix-based tools that you can access from the command line. Now, don't think that monitoring processes is only required for laptops and workstations. For example, this right here is an interface that monitors the performance and even the active tasks, the processes and the services that are running on my Synology NAS, that's a network attached storage, which is running a Linux distribution and actual processes that can be compromised. Also remember that processes consume resources, hardware resources, and we should keep an eye out for high resource usage in all our devices. Now, what exactly is high for us? Having a resource consumption baseline, or at least a reasonable expectation about how much CPU, how much memory, how much disk or network IOs, inputs and outputs, or your processes should consume. It's going to help you identify any outliers. And keep in mind that in all operating systems, high resource usage is not necessarily a confirmation for malware. If you're not 100% sure if a specific file should be present there and should be eating up your resources, you can use some public sources of information like shouldiblockit.com, which is going to provide you with some insight as to what is the expected behavior of specific legitimate and not so legitimate files that you might find running in your task manager. Disk and file system IoCs. Now, while we don't really encounter malware as a single file on a USB drive, a CD, or a floppy disk like we used to do in the 90s, even fileless malware, that is malware that doesn't reside on a specific file on the disk, it's going to have some interaction with your file system or your computer resources, and thus might reveal its presence. By looking at the file system and at the disk, we can also pinpoint some data exfiltration IoCs, because in order to steal some data, the malware will have to interact with the file system at some point. So some techniques here for getting data ready for exfiltration might include writing to temporary folders, temporary locations, masking the data as a log file, archiving, maybe encrypting it, using NTFS alternate data streams. We're going to talk about those in a future video, or even temporarily using the recycle bin on Windows. So make sure you keep an eye out for all these behaviors on your hosts. If you remember the MITRE ATT&CK framework, you can find these methods documented here as well. For example, archiving of collected data, encrypting or compressing the data that is collected prior to exfiltration, and data staging, again, which means collecting data in a central location or directory prior to exfiltration. Have a look over some of the malware examples on these pages here and document yourself as to what are the possible methods that attackers can use to steal data from your company. File system analysis can also reveal some indicators of compromise, because the file system is going to store much more information than the visible files that you can actually access, like timestamps. or who owns or who has last modified a specific file, when it happened, access control lists that dictate who has access to the file, and so on. You have specific tools at your disposal that help you get a better view of that file system, and some even in a graphical manner, but some command line tools are already available to you right out of the box. Like the dir command, the dir command in Windows. For example, dir/a match all the files and folders of a specific type. In our example here, age stands for hidden. dir/Q is going to list who owns each file. You can use this command to check for malicious owner entities. Another one here, dir/R is going to display the alternate data streams for a file. An alternate data stream can actually allow you to hide a file within another file in the file system so that it's not easily found using regular tools and by regular users. Now we're going to talk about alternate data streams in a future video. Disk space usage can also be an indicator of compromise. That's because malicious software can consume too much disk space for a number of reasons. First of all, they can be using it for storing files for later exfiltration. They could be generating excessive log information due to some brute force attempt or scanning or whatever intense activity it might be carrying out. It might be downloading additional content from the internet, especially if it's some advertising based type of malware or spyware, or simply because of bad programming. Not all malware is written by excellent programmers. And monitoring this space is one of the easier indicators to monitor, but you will need a tool to identify exactly where on the disk is the right operation happening, what process is doing it, who owns that process, when it was launched, and so on. Now, there are a lot of tools available out there for all the operating systems that show you how much space does each folder take on your disk. And among the classics would be, for example, Total Commander on Windows, or the disk usage command, abbreviated DU on Linux and macOS. Lastly, file handles. Every operating system keeps track of all the files that are being accessed by its processes. For example, on Linux, the lsof command is going to list all the open files under my username. And you can also filter this down to a specific process, for example. Now, security tools can keep track of these open files and try to figure out right away if there is some suspicious behavior right there, like a process trying to open too many files or files that it shouldn't normally access. Also, high volume writes, high volume deletions, and attempts to open, let's say, all Office documents at once on a single host might be an indicator of an undetected crypto malware that is running in the background. And keep in mind that ransomware in general and crypto malware is a huge topic on the CySA Plus exam. Next on the hosts, we're going to be looking for unauthorized privilege IoCs. Now, a typical phase during an attack is privilege escalation. So after the attacker manages to get some kind of access to the compromised host, they will attempt to gain admin access or root access to escalate their current level of privileges. Now, this is required to establish persistency, to modify system files, change system settings, or even pivot to other systems within the same network. Now, privilege escalation is usually carried out using some sort of exploit that matches some vulnerability that the attacker has identified on that system. This kind of privileged account usage is normally monitored or should be monitored and logged. So once privilege escalation succeeds, it becomes quite difficult for the attacker to completely cover his or her tracks. Now, you can look for a number of indicators here. Like unauthorized sessions, unprivileged users' accounts might show up as accessing privileged areas. Failed logins are normally logged by default anyway, but not as IoCs. Some users do mistype or simply forget their passwords, but too many such failures, especially for an admin account or a root account, is not something that you see every day and might indicate a brute force attempt towards privilege escalation. New user accounts showing up in your systems should be investigated as soon as possible, not to mention administrator accounts that show up out of nowhere. Guest account activity. If you have to activate to enable the guest account, make sure that they have very limited privileges and that you monitor whatever happens within those guest accounts. Because even a guest account is a valid account that can be used for privilege escalation or pivoting. How about privilege usage at abnormal, weird hours or times of day? Yeah, we know that IT people and admins sometimes don't have the sleep schedule of normal people, but even so, investigate those 3 a.m. logins, especially if they're followed by a lot of activity. Monitor your security policies. If you happen to see sudden and unexpected changes to the security policies, access lists, this might sometimes be the only indicator that you will ever find. If an attacker manages to change your security policies to accommodate their own malicious behavior, you might not see any other kind of alerts because they have basically paved their way towards their victims so that they won't be triggering any other alerts. Having a configuration baseline and periodically checking those systems configurations for baseline deviations might help you with detecting this. Unauthorized software is definitely something you should investigate. Simply detecting the presence of unauthorized software on a host might be enough to start investigating. Also, unexpected security tools installed on a server or a workstation is definitely suspicious as well. Even if the software itself is legitimate, like a valid Nginx or Apache web server, it's still abnormal for a workstation to be running something like this. This might be an indication of a compromised host or an insider threat. Now, when analyzing such software, you should be using some specialized tools that not only detect the presence of additional software, but can also create an investigation timeline of where and when the application was downloaded, which was the source, how it ended up in your network, how it managed to propagate, and when it was launched. This information can be also presented in a graphical user interface like Cisco AMP for Endpoints does. But the information is already there in the operating system. You just have to dig for it. For Windows, we have prefetch files, which log the names of the applications that got executed on the machine, along with a whole lot of details about those applications, including any dynamic libraries that they loaded while they were running. Thus, finding gaps in prefetch records might indicate a suspicious behavior of some malware trying to cover its tracks. Keep this in mind that on Windows, prefetch is disabled by default on SSD drives. Also, application usage information can be extracted from one of these two caches that you can see here on the screen. The first one can be opened by the registry editor, the second one cannot be opened, but can be inspected using file system forensic tools. Next up, unauthorized changes to the system configuration of a particular application's configuration might also be an indicator of compromise. An attacker might attempt to change security settings, open firewall ports, or disable some security protocols in order to proceed undetected. Now, on the hardware side, many attacks might be carried out using apparently harmless USB drives. They don't necessarily need to store a virus or some type of file malware, but their firmwares can be overwritten to make them look and behave, for example, like virtual keyboards or keyloggers or even wireless network devices, or running some exploit code that opens a backdoor into any vulnerable system owned by naive users who happen to stick any USB drive that they find on the desk in their computers. Persistence IoCs. Now, persistence in malware is any method by which malware can survive a restart, a power failure, or a user logging off. Now, two of the most common ways of ensuring persistence are writing information into the Windows registry, storing malicious information or code in the registry itself. Now, fortunately, anti-malware tools can also scan the registry for suspicious startup items, deleted keys, or for any deviations from a pre-approved template. Unfortunately, the regedit tool in Windows doesn't display the timestamp for registry changes, but this information can be analyzed by exporting the contents to a text file or by using a specialized tool such as regdump. Now, some things to look out for inside of the Windows registry are auto-run items. A very common method for malware to ensure persistency is to write itself an entry inside the auto-run list of applications. Now, these items are not visible to the average user, so this is a great place to hide a piece of software that automatically launches with the operating system. Next session is the services list. Suspicious entries in this key here might indicate that the malware is running hidden as a background service, very often using one of the names that Windows uses for its own services. File associations, another popular tool for tricking users into launching malware, is by changing the application associated with specific extensions. Now, users expect to open, let's say, TXT files or docx documents with Notepad or Word, and instead they launch some malware binary. File extension registry entries are right here on the screen. Last but not least, scheduled task. The second common method for persistence is for an attacker to set a scheduled task to run automatically so that their malware is going to run whatever they want it to run. Fortunately, scheduled tasks are easily displayed using this task scheduler, and Windows also keeps track of all the previous run attempts, so you also get a run history just to figure out when each entry in the task scheduling list has successfully run in the past. And also it stores the information of whether the task succeeded or not. Finally, application IoCs. I know I'm repeating myself here, but studying application behavior with the purpose of finding indicators of compromise is made much easier by having a documented nice baseline. Now, in case of applications, this means understanding how is the application behaving in a legitimate manner. How does it interact with the processes, file system, or network? How is it supposed to work as opposed to how it is working when something suspicious happens? One more thing, when we say application, we should include virtualized applications as well. Applications running on clouds or even applications running on mobile devices. So don't forget about those. Now, let's look at network connections from an application perspective. What should we look for in an application to determine if it's suspicious behavior or not? Well, starting with the network, you can list all the open ports on a host with a tool like Netstat, locally or Nmap to perform a remote scan from a remote location and look for unusual ports. Those might be applications listening on strange port numbers or simply applications with open ports that shouldn't have any open ports. How suspicious would it be to find Notepad.exe listening on a network port? Also, don't just look for listening ports, but also look for outbound connections, as they might be an indicator of malware communicating with its command and control center. Next, we have to look at unexpected outputs and errors. Attempts to exploit an application or even to scan it for vulnerabilities might produce errors, or even more errors than usually, which should be visible in an application's log file. This is especially useful for web applications, where we might be seeing code injection happening, directory traversal attacks happening, and many other attacks that are actually easy to spot in the requests stored in a generic log file. Service defacement. This is usually more obvious and easy to detect, since defacement, especially for websites, it's an action that replaces some web content, usually the landing page, the index.html page of the first page that the user sees when connects to the website, with the attacker's own content, with the purpose of being visible. Hacktivists often do this to promote their own message on the homepage of some company that they do not agree with. Finally, service interruption. Here, application and service crashes are a common event, so not every error or crash that you encounter will be related to a security incident, but they can lead you to suspect that a security breach has occurred. Now, some common patterns here would be manually disabled services by an attacker, especially security services, in order to cover tracks and evade detection. Compromised processes with malware code in them that can lead to frequent errors and crashes, because not every exploit is a flawless exploit. And even disabling a service due to a denial of service attack. Now, running services can be viewed in Windows in Task Manager, as you know, and you can also use some command line utilities like netstart, for example, on CMD. Or if you like PowerShell better, you have the get service command. Kind of gives you the same output. On Linux, services are called daemons, and you can list them along with the rest of the processes using the ps command or the top command, or using the service command or the systemctl commands. And then on the host, we also have the applications and their logs, and that's a gold mine of information about potential indicators of compromise. Now, since most applications have some sort of logging mechanisms in place, properly analyzing these logs can reveal a lot of useful security information. For example, for DNS, we can look for what queries were received, including malformed ones, a list of destinations accessed by internal hosts, what kind of websites are users accessing. You can find those with some bad reputation in there. You can look for statistical anomalies, like very large number of resolution failures, which might indicate a denial of service or a malware that is constantly trying to reach its command and control center. Now, for web servers, we can look at the HTTP status codes. We have codes starting with 4, which indicate client errors, codes starting with 5 that indicate server errors. Some web server software can also log the request and response headers, where you can find information about which data was being sent to the server, information about cookies, and sometimes even the user agent header field that identifies which application as a client, as an HTTP client, was initiating that connection. This might provide some useful insight. Logging the requests makes looking for past intrusion attempts, especially for web applications, very easy. Now, when it comes to FTP servers, you can just simply log the entire activity of all the clients, all the connections, all the commands. They're all text-based commands. You can easily spot brute force attempts or attempts to access restricted areas because they're also going to be logged. For remote terminal connections like SSH, the SSH protocol is concerned only with the protection of the data channel itself. So you will not find information about what commands were actually used or which files were transferred, but instead you will see some session information, and of course you will see the failed authentication attempts. For example, a large number of failed logins using multiple encryption methods might indicate a reconnaissance attack of an attacker trying to figure out what type of encryption is enabled on your SSH servers. For database, SQL logs, beyond the usual logging generated by most SQL servers out there as part of the maintenance tasks, logging access attempts is very useful from a security perspective. Going one step deeper, SQL servers can also log all the queries that they received and their execution status, allowing you to drill down into the actions of every person or application that accessed some piece of information from your databases. New accounts are also important to monitor because one way to maintain access for an attacker is to create his or her own account on a compromised host. On systems with hundreds of accounts, user-based or machine-based, one rogue account can easily be overlooked and ignored. This is why account creation as well as privilege assignment must be very well defined and part of a well-built change controlled process within the organization. Now on Windows, remember that we have local user accounts that can be administered from the local users and groups console, while domain accounts would be found under the Active Directory users and computers. On Linux, on the other hand, we have some tools that help us with account management. At a minimum, you can start with the W command for who, which shows you the currently logged in users. Now, if you don't happen to catch any suspicious accounts while they are logged in, have a look at the login history using the last log command and see which of these users have recently logged in into your systems. The list of last logins is useful because some attacks might remove their traces, including the accounts that they have created. So this might be the only place that shows what happened in the past. You also have files like var log auth log, which show past user creation commands. And also fail log can track authentication failures. Don't forget about virtualized applications because many applications today are designed to run in virtual environments. Of course, this brings a lot of benefits from an admin perspective, but security challenges also change quite a bit. Now, discovering indicators of compromise in virtual machines can be done in a number of ways, starting with the process and the memory. For process and memory, we can use hypervisor VM introspection tools. That's just a fancy way of saying that the hypervisor, being the master of all the virtual machines and the underlying hardware, can access the memory of each virtual machine. Also, suspending a virtual machine will write its entire memory contents to the disk, a process similar to hibernation in desktops and laptops. This state file can be analyzed just like a memory dump. Then we can also look at the disk and generally any kind of persistent storage with virtual machines, because analyzing the files within a virtual machine is just a bit easier since the VM's disks or disk are already in an image format, easily accessible. So looking for IoCs in there is easier since everything is already in one single place. You don't have to deal with hardware components. Also, you can have access to the recovery of deleted files. That's also possible because those virtual disk image files store the free space as well. And don't forget about system logs. Applications in virtual machines sometimes undergo some recreation processes. That is, sometimes even for an update or a fix, the entire application might be destroyed and recreated as a new virtual machine from a new disk image and then have its configuration reapplied. Now, this is very convenient from a management perspective, but if you don't have a centralized remote logging in place, any locally generated logs will be lost. So make sure you don't lose those if you're facing an infrastructure rebuild or a simple denial of service. Now we do have to end at some point, so let's end with mobile applications IOCs. Now, looking for IOCs in mobile devices and applications is sometimes very difficult due to the fact that mobile devices are sort of black boxes nowadays. For most devices, storage is soldered on the board of the device. It cannot be extracted, and sometimes it cannot even be accessed using third-party tools. So you're going to run into difficulties created by the security controls of the device itself, like the device encryption. Screen locks also can prove to be extremely difficult to bypass as well. Starting with iOS 5, I think, and Android 7, devices are encrypted by default. So for unencrypted devices, a JTAG interface attachment might be possible to directly read the contents of that storage device. Now keep in mind that besides the information that you might be able to extract from a mobile device, there are two more sources of information and potentially of IOCs. First one, we have the cloud. Now, this is where the backups live, sometimes even the configuration of the device itself, the user accounts, their passwords, the login data of all the application, their session data, everything, including the access logs, are going to be stored in the cloud. Now, depending on which cloud that is, you might be able to get some really juicy information from there. Secondly, don't forget about the carrier itself. The carrier is going to handle everything related to your calls, your voicemail, your SMS service, the network traffic activity, which antennas your phone was next to at any given point in time, geolocation information and such. If you do have access to this kind of information, which is not just a technical but also a legal matter, make sure you get as much as you can, because that's going to be a trove of information about that specific device. Okay, now this was a huge chapter, and honestly, it's a huge chapter in the exam as well. That's why we're spending so much time talking about these IOCs. So for the exam, make sure you remember. I cannot remember by heart. I have to check my list here. So let's see, we talked about denial of service, right? We talked about beaconing IOCs, peer-to-peer communication, rogue devices, scans and sweep events, non-standard port usage, data exfiltration, covert channels, malicious processes, so everything related to the host like high resource usage, file systems and the disks, user privileges, unauthorized software, unauthorized device changes, persistent IOCs, application IOCs, application logs IOCs, new accounts, virtualized apps, and finally mobile apps. Make sure you understand and you can easily provide some examples of how these IOCs are supposed to look like, and at least an idea about how they can be obtained or extracted. So if you found this useful and informative, don't forget to like and subscribe. That's all I need to keep this channel going. Thank you so much for your time. Best of luck at the exam, and see you next time.